This is stream number 31 in DataDisintegrator. To-do-driven development. DataDisintegrator being that which pulls apart bytes and assigns meaning to them based on a description of the data format written in a domain-specific language. Here is an example. A GIF file, or a GIF file if you prefer, being composed of a header part, trailer part, data blocks, logical screen, which has a descriptor, a color table maybe, a descriptor telling us how big the image is. Working on implementing this in Rust. Had this in C, called it the decomposition library. It's now called the ingestion library. We're using an abstract syntax tree to break down data into elements, determine their meanings. Essentially, here's an input file. We walk this input file in order with this description of the data. And I can no longer run the tool because I broke the format, but we're going to try to get that back. Wanted to show an example every time I describe what we're doing, and I broke it. Ah, it's broken. Unable to parse file. Change the syntax a little bit around here. But you can imagine that we would parse these first 3 bytes as the signature of the file, and then the next 3 bytes as the version number of the file. Make sure that the signature and the version are okay. The version becomes the overall value of the header, so we would print that out, which is the 89A there. Go into the logical screen. That's the first 2 bytes there in the logical screen are the screen's width. So that is 300 if it's little endian 16-bit. And so on. Calling this to-do driven development because I'm looking at all the to-do markers in my code and in the comments of my code to kind of remind me what I still need to work on. So I think we should make sure that the today command. Wow, it took a long time for my bot to answer. Implement parts of my parser engine. I think I want to avoid the word parser because it means something specific. And really, I'm in the ingestion library, not the parser. So let's update this. So that's an edit com today. Today, Raimu is implementing parts of his Mernin Nightshade dude. Aren't you watching Brooke Zerker? Brooke Zerker's working on you. Not you, but you. Yeah, we're watching both. You're the multi-streaming chatter. Multi-stream consumption. I could just imagine you have like 4 monitors set up and you're like watching 4 different streams and you're like got the keyboard accelerators out, like jump to that one, comment, jump to that one, comment, jump to that one, and simul content, comment. I'm implementing parts of my blank engine. Just 3 monitors. Okay, well, that's still cool. And the parts of his I don't want to use the word parser because it's overloaded. I could use data parsing engine. Then we just add a word to make it non-ambiguous. Brooke Zerker, what? It's too soon to rate. Too soon. You have to, I'm sure that you have had a great stream. I was watching your stream for a while I was eating breakfast. Now you have a double Raimu. You got to change that monitor over there, Nightshade dude. Change it to I don't know who's streaming in addition to us, but pick another streamer, right? Make sure you keep those skills sharp. Hello, Raiders. I'm just trying to figure out what I'm doing today. And I'm updating my today command. We're just starting. It's only been like 5 minutes. Hello. Let's give an intro since I'm just starting anyway. Working on DataDisintegrator. It pulls apart bytes, disintegrating them, so we're removing the integration of those bytes together so that we can assign meaning to the pieces based on a description of the format written in a domain-specific language. So here's a GIF or GIF if you prefer, the structure of one of those image files. It's composed of a header and a trailer, and in between we have data, and we have this thing called the logical screen. Logical screen has a descriptor which tells us how big the image is. The header marks it as a GIF or GIF if you prefer, and has a version number. So if I were to show you what the raw bytes are, you can kind of see that GIF89A, that's the version number there. And that is the width, and that's the height. So I'm making a tool that can, you give it a file, and you give it a format description of the file, and it kind of figures out where everything is, similar to Wireshark, which is a popular tool that you can give it a bunch of bytes from a network card, and it'll tell you where all the packet boundaries are, and in each packet it'll tell you the types. So there are several steps of this. I wrote it in C and C++ years ago. I'm porting it to Rust because just for fun, for giggles and all that. And there are three main parts: a lexer and a parser, which together you can think of as a compiler, turns this custom language program, if you will, into an abstract syntax tree. Why is it abstract? I learned the other day by reading the definition of it that we're abstracting away all of the white space, the punctuation, all of the things which make the grammar disambiguous, and we're just getting down to the nuts and bolts. So actually, that's not the right word. We're getting down to the essential structure. So this would be like a root node called GIF, and then child nodes header, logical screen, a while loop, and a trailer. And while loop has children next, an if statement and a data, and the if statement has a break in it. So like a data tree. And we're going to traverse that tree in order, apply it to this data, and do cool things with it. When we stream, do we get copied to Twitch, or do we just send a ref out? I say we get cloned. So that means that by now I have 31 other Raimus out there. That's what I think. Now, if only we could collect those clones into a vector. Would it be a copy, clone, or just a ref? Oh, we should allow that. This is dope AF. Why does AutoMod think that dope AF is a bad word? Yeah, we are immortal. Just keep cloning. When in doubt, clone it out, right? That's what we say in Rust. When in doubt, clone it out. That's not what we actually say, but it rhymes, so it's cool. So I'm doing test-driven development, but I'm also doing to-do-driven development, so it's both TDD either way. So certain parts of the ingestion library. Already did the lexer, already did the parser. I can go into detail if you're curious, but we're doing the ingestion library. We're using this AST to break down data. And so, for example, here's the representation of a statement in the AST. So it's an enumerator type. You could either be parsing something, you can have an if statement, for loop, while loop, etc. Or down to just like a return statement or a break, simple things. And yeah, I have to do implementation of for loops. I think we'll do that today. And then I got to do binary ops. I got to do maps, sets, and vectors, and unary operations. And then I got a bunch of other things I got to do. Testing, AF, exactly. Testing dope. Shrug. Yep, testing all the things. All right. So test-driven, to-do-driven development, I got to write a test for that for loop first. I have a test for the while loop, right? Here we are. Here's like an example unit test. So we set up a logger because we have diagnostics being logged out. It's nice to see those. Then here's a test program that we're going to compile. And then we're going to construct a bit stream with 1 byte in it. And then we're going to ingest that bit stream with that the syntax tree we get from compiling this, and then we're going to say the bits represent a foo. So good thing we told it what a foo means. So a foo is going to first while arg, and while arg is true, we're going to parse one bit as an unsigned integer called inner, and then break out. So this is going to assert that we have an error and we don't actually parse anything because arg is not a legal expression for a loop. It is a bad condition. Whereas all of these compute to false. You could say false, no, off, empty string, 0, 0.0, positive 0, negative 0. They should all match false. So the way I tested if it's false is we don't go into that loop, but we do parse one bit. So if we parse one bit, we didn't go into the while loop. If we were to parse 2 bits, the inner and the outer, we would have parsed 2 bits. So that's what the true cases do. True, yes, on, 1, 0.1, plus 69, negative 420. All of those are true. So we expect it to go in the loop and parse the inner and the outer, so we get 2 bits. Right? So cargo, next test run. Make sure all of our tests pass, including these lovely ones. So let's make some new ones. While copy paste, let's rename this a 4. And we're going to do a mod 4. But wait, you say, isn't 4 a reserved word in Rust? And yes, it is. But you could do this nifty trick where you could say, I want to call it 4. So let me do it. And it does, it's like a raw word, I think. Just like you can do with raw strings. You say, I really want to call it 4, damn it. And it will let you. That's how cool Rust is. So we have a module called 4. We're going to have like a 4. Actually, I'm just going to do a global replace of all 4s or whiles to make it 4. We just have to fix the loops. So let's globally replace the 4 part with a 4 I equals 0 semicolon space. Go to the end of the line, go back 3 characters, and do I forget. Do I need a semicolon there? I don't remember. So let's consult the grammar for a for loop. For a parentheses, something equals something else, semicolon. Oh, I do need a semicolon, another semicolon for the expression. So back here we go. Semicolon, plus plus I. All right, so that's a syntactic. Oh, wait a minute. No. Plus plus I semicolon, because of an oddity in my grammar where the span statement always has a semicolon in it. Don't ask me why. It's a complicated answer. Left Proxorker to get some work done and come back to Rhymer. Let's go. That's right. Let's go. Super fun. Reminds you of JS where we can just delete anything in the language and replace it with something else. Yep, it's that flexibility we need. R hash is short for really, I guess. I think it's short for raw, but you could think of it as really, and Rust won't mind. Also, the wrapped. Hi. Okay, I just want to make sure all these tests are valid, and we got to add more tests because, like, we got to play with the loop variable, right? So yes, this should not have any bits. These are all like, there's a condition. Oh, hold on, we got to fix that. Remove that that parentheses, errant parentheses, right? And also we got to fix that. Okay. So all these are great. They're just testing the condition part, but they're not playing around with the loop initialization and the increment. But they're a good starter, so let's run these. Run them. And they're going to fail because we have not implemented. See, not yet implemented the actual statement. So let's go in there and do that. Right, so I'm just going to begin the implementation by copying another implementation Because, you know, I've already written it. Why should I have to write it again, right? So execute while statement gets copied to execute for statement. So keeping it like alphabetical, because alphabetical is cool. It is execute for statement. And going back, not back that way, but back this way to our tests. So I want to run it again. I think this should test it now. No, we have, I've named the test the same thing, I think. Oh, how did that happen? Oh yeah, okay. I forgot to remove the dot dot and do a fill struct fields. We aren't using the loop variable in it or next yet, but that's cool. We will. So back to tests, run the 4 tests that are right there. Hey, they all passed. We're done, right? Hey there, Geo52 Ray. I'm trying to figure out what that 52 means. Now, were you cool enough? Well, of course you're cool enough, but were you subtle enough that 52 is perhaps the ASCII code for a letter that if I insert it, your name like flows in a certain way? What is the ASCII code 52? Well, if it was octal, it would be the star. So you could be like Geo star ray. If it's decimal, it would be 4. So you could be Geo 4 ray. Both of those work, right? You could be a star ray, you could be a 4 ray, Geo 4 ray. Simpler. Is it delete encoding? So it's like an S and then so it's a Geos. See, I'm not into the memes and the elite speak so much. So I don't know. But maybe it's 52 hex. Could be. Ah, stupid ads. I'm looking at that table. 52 hex would be an R. Geo Rure. Is their age? Nah, we can't do that. We can't say that. That's not nice. I shouldn't be picking on Geo 52 Ray. Much younger. Okay, so let's make some tests that force us to use the loop variable. So let's just grab a test, I guess. Let's just grab one of these. Sure. Except for we don't want to have an error. And I think we'll continue to do the counting. So let's do 5. And then this is going to force me to actually do actually no, if I just do I, it reduces to true as long as it's non-zero, right? And then I can do a decrement. So how many bits is that? If it was 0, it would be 0 bits. So it should be the same number of bits as the initialization, right? So this plus 1 should be 6. We'll get a problem that will collide. But if I do that, it should actually work. Hopefully. Otherwise, we'll have to fix that. And then this is test for with using loop variable. There we go. We could actually use I here, and that would be even cooler. What if we do that? So now it's 5 plus 4 plus 3 plus 2 plus 1. 5 plus 4 is 9, plus 3 is 12, plus 2 is 15, right? Plus 1 is 16, plus 1 outside is 17. So we should have 17 bits. So I should make sure I have at least 17 bits here. There. Now we have plenty. We've got 24 of them. So it should parse 17 bits, right? It's not going to work. It will say that there was an error. We panicked because I is unfound in the loop variable, right? So we haven't done the loop initialization, so it can't find I. So in statement, no. In context, we should pass in those lovely things: loop, variable, initialization, and next. Okay, they are a type string, expression, and a box span statement. Box span statement. All right. Why type it when you can copy paste, right? So copy and then paste. And let's give them all types of what was it again? String, expression. Okay. String, expression, and a boxed span statement. Statement. Okay. You just finished implementing %C for your printf. Now the hard part comes, all the different int widths. You're definitely not looking forward to the floating point handling. Are you programming it? I forgot to ask. You were talking about this in Brooke Zerker's stream. Are you programming it in JavaScript or C or what? Because you might be able to just cheat and use the languages that you're using, use its own runtime library to do some of that. Program in C? Well, why don't you just cheat and use scanf? Or sprintf, I guess. I take it you don't want to cheat and you want to actually implement it yourself, but you could do like A to F, or was it F to A? F to A? Is that a thing? I know there's A to F. Convert a string to double. Is there an F to A? No. What would it be like D to A? No. Does A to F talk about what the inverse is? A to Y, A to L. String from D? String to D. You could cheat and use string to D. Convert an ASCII string to... No, that's the other way. We want string from D. There we go. Convert a floating point value to a string. You could cheat. Just saying. No libc? Ah, well. What's a fun? And I'm just kidding. I'm doing some of that cheating on mine. So I have the equivalent for me would be the data values from trait. So there's a try from some value for usize, for example. So we say that floating point to usize is ambiguous, but like unsigned integer, we can just do a try from the underlying type, which is u64. So to do try from u64 to self, which is usize. What else? I had more casts, right? Cast to decimal. What were the more interesting ones? I guess that's also, we have to do that in the Lexer too. So this is the other way. This is scanning, not printing. But yeah. Yeah, we're cheating and using the standard library because we can. Because we have it available, but just for fun, I'll just show what we do. Since it's similar to what you're doing, only backwards. So parse is very handy. It's context sensitive. So if we tell it we want an I64, parse knows that this slice, which is a really complicated type that ends up being a string, says take the string, parse it as I64, and you basically say the same thing for U64. But for like if it's octal, we use from strradix instead. Actually, do I have to say that, or can I? We have to have some type there, right? So we have to kind of show our hand there. Actually though, there's no common trait for all integers. If there was, I could have made this generic on every kind of option of an integer. As long as we could get from the actual type its base. I had to do some special tricks when for base 2 and 16 because we have the B or the X, and the from str radix doesn't like to see that. Fun times. We're done with that lecture. We're moving on to this. So I think we're just doing some extra stuff before this main loop. So I think the loop variable is, we do the same thing that we do with assignment, right? So actually I can go look at that. Execute assignment. Yeah, so we have this, why don't we just copy this? Because it's almost exactly the same, right? And just paste it here. So find the loop init expression, and we'll call it loop init again. And then we create dereference or create a mutable loop variable. So we get a loop variable. If that's not okay, then the composite's in error. Otherwise, we do the direct assignment, and this is the part we don't want to have yet. This we're going to return the error. So this is the loop initialization. Loop var is a string. What does this want? A reference. I can manufacture a temporary reference. So reference wants to have as a vector a reference part, right? Okay, and now it's going off the screen, which is making me uncomfortable. So I hit enter. Okay, import that, and then fill fields. So the identifier is the loop variable. We're gonna have to clone it. That's fine. Clone. Indices is just an empty vector. Cool. So all that ridiculous extra stuff just so that we can turn a string into a reference. All right, so this technically doesn't need to be a string. It can be an str. I think that's what it's trying to tell us, as long as I do like a toString here. Okay, we're not using loop next yet. So if I'm not careful, if I don't use that loop next and do that decrement, we'll have an infinite loop in our test. So we should do that, right? Loop next. Basically, we need to execute this statement at the end of the loop. So there is no continue in my language. It's when we get to instead of having a condition, right? Right, wherever we have this condition, before we evaluate the condition, if it's right here, I think, or actually right here, we need to execute that loop, the next loop statement. Execute statement loop next. This returns something, right? So we have to do a match on that at most. Okay, so break. Do we allow a break statement as a loop next? I think we should. So also we'll return. I think for break, we're going to return a next. Just like we do if we get out of here. So actually, we're supposed to put that there, I think. Return returns a return, and error returns an error, right? Error returns an error. And a next, I think we just do nothing. Okay, it's unreachable. It's unreachable because this continue should do nothing instead. We want to have it fall out to after the match. This is unreachable. Oh, I see. This should not do a return, right? This should actually break out of the loop. Or actually, no, this, I guess we do want to break because then it falls out naturally, and probably my while loop should do the same. And also this, right? Should break. So this is evaluating the condition of the loop. If it's false or nil, we break out. Actually, a try from nil should give me a false. So this is actually unreachable, I think. Yeah, I don't think we ever get nil. Oh, wait, yeah, we do. If it's a nil, we don't even try to match from. Actually, then can't I just oh, this takes a value, not an option value. So yeah, we shortcut down to here if it's nil. And we just want to break as if it was false. If it's true, then we do continue the loop. But before we continue, we want to do the loop next. So we're not doing continue anymore. We're just doing nothing there. I think this is good. So what's this warning here? Seem to be trying to use box because they're just T. So it's just telling me I don't need it. It'll auto deref the box probably, right? Cool. And let's run the tests. Hopefully, it does not infinite loop the tests. Great. We only failed one of them. So we got 6 instead of 17 for this one. Okay. So it only did 6 bits. So I guess it's not using I. It should though, right? Shouldn't it use I here? So if I starts at 5, it should have taken 5 bits. Then the next loop it should have, oh, we have a break. That's why. Don't want that break. We actually want it to loop. And yeah, don't I want it to just loop? Oh, actually, no, I don't. Because this was intended to only go through the loop once no matter. So if it's true, it would do infinite loop. Yeah, okay, so let's make sure I fix this one. Panicked on an error. Collision on inner. Okay, yeah, that's a problem, right? I was afraid of that. The ignore pattern is assigning to inner, but it's not allowing reassignment. I need to allow that. So that's in statement. Execute part statement, right? Actually, this should be called execute parse statement because we renamed that. So when we parse some bits and it's a local, we should allow reassignment. I think that's the problem, right? It's going to say it's a collision. And this is supposed to return a vacant entry. And I think that is okay. Because if the local already had it and we insert it again, it just replaces it. This part though, it's only a collision if it's actually a part. If it's a look ahead or an ignore, then this should actually work differently. How would this work differently? I think what we do is we just we would always get the entry, but only if it's a part would we do this check and the insert, right? No, we'd only do the check. Okay, so yeah, so let's turn this around. So we first say let possible entry equal that. Okay. Then let me think about this. I don't want to have it return always. Actually, then I don't need to do this. I could just do a check in here, right? And I just turn this around. If let okay, then do this, else that. And then in here, I don't need that. Here I would say if it's a part, then it's an error. Only problem is this is going to do a diagnostic and it's going to set the composite error. Bummer. I think I want another an alternative then. We're already doing that check anyway, so why don't I just do that, like if it's a part, do it one way, which would do it this way again. Then we don't, so like this, else this. But I still have to do the insert part there. I just need another function to do that, right? And now you handle the %% case. Woohoo! Greetings, program. C17R, how are you doing? So if the goal is to make a part, then we have to add it in context. And if not, I think we're going to do like a similar thing where we like maybe do a maybe add. So we would say if maybe add child in context if unfound. That's what I want to do. And if it adds it, then we insert it into the locals. So that means, yeah, it's telling me I can just do that, right? So we need to add that method. That's an alternative to this one. I don't need the context because we're not returning an entry. It's going to look a little bit like this. So we don't need a lifetime because we're not returning that whole thing anymore. We're just returning a Boolean to say if we inserted it. So this would be like if let hashmap entry vacant entry, all this stuff. Then this, right? Oh, actually, okay, so we should put the part in there. And what type is part? Component. Okay. Yeah, I think that makes sense. So it's just going to take a part component. That's data component, right? All right, and then so if entry.insert part. and true. Else false, right? So it's similar to this, only we're not returning the actual entry there. We're just saying whether or not we actually inserted it. Because I don't want to do the insert on this because I believe that would replace it always, right? Actually, maybe that's not such a bad idea. If it did have it, the value is updated and the old value is returned. So actually, maybe I do want to do that. So, because we would want to replace the old one, right? So what if we call that replace child in context? No, I don't want to replace a part that we parsed. So I definitely don't want to do that. So we don't want to do anything if it's unfound. Actually, in fact, it should be more than that. If it's found and it's not a local, it's a problem. Well, don't we already we don't need to worry about that though, right? Because this is only being used from a loop thing, right? Or no, it's used from if we have a name and it's not, the goal is not to make it a part. We should do a collision check, right? It's if it is a if it has bits, I think. If it's not a local. So then I should actually do a check here. Right? If it does not, no, it's more complicated than this. Add child if unfound, but it could be found. It's allowed to be found if it's local. And if it's found and it's not a local, then it's an error. I could just say what it is. Add child in context if unfound or local. Actually, then add child in context unfound or local means that it's not a part. It's not part. Yeah. And actually, I don't want it to return a bool after all. I think I want to have it return a mutable reference. And no, we're already passing in the part, right? So the name of this is kind of wrong because it doesn't actually add the child. It adds the child's entry. Add child entry. This adds the child in the context, if not part. Yes, okay. But it's also got to return a result, right? Well, not really. I think I do want to actually return a result, but it doesn't actually need anything in the success case, right? We're just, it's like an upgraded version of a bool to say that it really is an error and you should do something about it. So, actually, does that mean there are 3 cases? It was either an error or we inserted it, which means it's a true, or we didn't need to insert it, so it's a false. because we use that down here to insert it if we needed to. Maybe. So then if it would be like if let okay found, well, inserted, added, if added. And then I got to turn this around, right? I have to say, let it be that, else it's a different kind of error. Well, we want to return the error scope, right? Okay. I think that's what I want. This has to do a bool then to make this work. So if our goal was to make a part, then we need to add a child entry in context and get an entry back to insert. Otherwise, it's an error. If add child in context if not part succeeds, then we either added it or not. If it didn't succeed, we're returning an error. If we added it, then we have to create the local. If we didn't add it, then we don't need to create the local. Enum instead of bool. Well, I kind of wanted the result, because the result should translate into a actual error. Like the AST has an error in it. It's erroneous. A bool is like not strong enough in my mind. Okay, so if the entry's vacant, then it's okay, true. If it's not vacant, so that means I gotta like turn this around and do a match on it, right? So this is vacant. And now we got to figure out what to do if it's occupied. If it's occupied, then we want to see, does it exist as a local? If self.locals.get name else, if it exists as a local, it's okay, false. If it doesn't exist as a local, but it's a key child, then it's a part, and we want to do an error. Right, we actually don't need the name, so it's is some. Entry. Here's the part I don't quite like. We passed in a part and we inserted it, but the caller, like it works differently than this other one where we have to insert it. We also forgot to set the composite error and do the diagnostic here. I'm just wondering, like, do we not do this insert? So there, maybe we return an optional vacant entry. Just so that it's like similar to this one. Maybe, yeah. So that means we have a lifetime, and this complicated type goes instead of bool, it's option of that. Even more complicated. So then this would be none, and this would be okay entry, and I wouldn't do the insert here. Wrap it in sum. Yes, I do want to do a sum. Okay, it's not too horrible. So yeah, this then will do if okay Actually, we want to do a match because there are 3 possibilities. So it's okay, some entry. It's okay, none, or it's an error. Error does this. Okay, none does nothing. Okay, some does, actually, it doesn't really matter, does it? Oh, sorry, yeah, entry sum, so there's no part anymore. Entry sum has to actually insert the part. There we go. And this locals insert, we gotta do that too. Yep. And we get rid of all this stuff. This doesn't have a part anymore. Okay, so does this look good now? If the goal is to make a part, then we're adding adding a child entry. Let's get rid of entry because it's not ambiguous anymore. It's just add a child. They both return an entry. Add a child in context with the name. And if that's okay, we're inserting a part. Otherwise, it's an error. We're returning early, right? If it wasn't to parse a part, it's like a ignore or a look ahead, then we add it if it's not already a part. If it worked and there's a vacant entry, we insert it. So really it's not add, it's like find vacant child entry in context or something like that, right? Yeah, it's not add, it's like find vacant, try that again. Find vacant child entry. And then I got to think, like, how can I shorten that? Actually, this should be find vacant non-part child entry in context. And we can remove the if not because it always tries to find it. And if it can't, it's an error. Okay, so those names are horribly long, but they're descriptive now. Find vacant child entry in context. If it's okay, then we're inserting into that entry our part. Find vacant non-part child entry in context. If that succeeds, and we've, so I can remove the word vacant here. Because it's like, it might be vacant, it might be a vacant entry or not, right? In fact, I could just have it return the same thing that entry returns, which is entry. And let the outer do a match, right? Vacant or non-vacant. Maybe that's better. So what is that? Just entry? And then this would... thing is, we have to do a match on it already. So it's after we've matched, we've consumed it. So yeah, let's just turn this back to vacant. Okay. So if the name is a little weird, it's like we're finding a vacant entry, and if we do find it, we get it as a sum. But if we didn't find it, it's still okay. We just didn't have it. And an error is that it was not a it was a part entry. Okay, it's close enough. You don't need in context since the struct is context. Good point. Good point. In fact, you get a point. Points, Geo 52 Ray 1. Now you have 5 useless internet points. That helps me make the name shorter. It's a little bit shorter is a little bit better. Yeah. Well, you're welcome. Thank you for helping out. I think this is good now, but looks like we got an error somewhere. So what did I do? Why is that a problem? Oh, because it's parse. Yeah, wait. Why is that a problem? Doesn't live long enough. Oh, right, I have to use the context. Okay, we're good now. Little bit of lifetime magic. Because there are 2 references, unless I actually name this reference, it doesn't know if the reference that's in this entry came from self or came from name. But if we say context here, then it's like, oh, okay. Because studying this code, it's this namespace that goes into here. They only that has to be context. I didn't explain that absolutely correctly, but the fact that you use the same lifetime for self and for the entry, because we got the entry from self, then it's happy. Okay, back to I guess the unit tests. Just run them all. Okay, we're failing loop variable test. So still, we're off by 1. Did I count wrong? I think I might have counted wrong. So the first time through the loop is going to be 5, right? Then it's going to be 4 more, which is 9, and then 3 more, which is 12, and then 2 more, which is 14, and then 1 more, which is 15. And then 16. Yeah, I did count. I am off by 1, right? 5 plus 4 plus 3 plus 2 plus 1. And then it'll be 0, and then breakout, and then 1 more. So that's 9, 12, 14, 15, 16. Cool, we're done with for loops. It was that easy. So I had to do 2 things overall, right? I had to kind of copy, execute while loop, and I had to change a little bit what's going on inside of here. Break, and then do nothing there. And then I had to have the loop initialization, which is we get the right-hand side, we get the left-hand side, and then we assign them. There are lots of ways we can get an error. We can get an error if the right-hand side didn't evaluate successfully. We get an error if the loop variable already existed. Right? Actually, how does this fail? It's not that it already existed. If it existed, and it's not a local. Not local, right? The entry is occupied as a keyed child, and it's not a local. It can exist as a local variable. So I should probably have tests for that, right? We should have like a test where we using loop variable existing local. So local I should still work. It does. Okay, but then if we try to use a part, it should fail. So here we'll do an I, which is a UI I1. 1. So we parse a bit and have it I. So this should actually fail. So assert that there is an error, and it should only have parsed 1 bit, right? For existing part. This will fail. Yeah, I is not local. Passed. Do I care about like checking the value? So if I say like I equals 42, but then down here, like I return I. Now the value of foo should be 0, right? Because it repurposed it to count it down to 0. I think I should do that. So assert equal to data value unsigned integer 0 for, I want to name this foo because that's what it is. Foo dot keyed children dot get foo unwrap value. Unwrap. Or I guess I could put some. What's the error here? Cannot move out of shared reference. Okay, we'll just make that sum. Then I don't have to asref it. Cool, and we're running that. Failed. Because, oh, it didn't exist because it's a local. Wait, no, I should have gotten a value from that. Oh, hold on. It's not, I shouldn't be looking for a keyed child foo. I should just be looking at the value of foo. Duh. Yeah, it passed. Great. What does the minus do? Yeah, it ignores the input. So it's just to show you how that's done. In the grammar for a statement, I tried to make these one rule, but I couldn't get it to work. So if you just have an identifier, so if it's just like this, where it just begins with an S or begins with a UI, right? Then it is a parse statement. But if you have a goal in front, it, yeah, actually, they're both parse statements, but without a marker in front, it's a part. But if there's a marker in front, it becomes a goal. And so goal has 3 values. It has part, and it also has look ahead and ignore. So if it's a minus, it's an ignore, and a plus is a look ahead. So how do I find that? Because I can't search from that file. Here we go. I can just click that. So a part means that we keep the value, that we keep the name in our list of children for the composite, and we remember that it actually was constructed from bits of the input. A look ahead means that although we constructed its value from parsing some bits, we're only using it temporarily to look ahead, and we did a rewind of the stream afterwards, so we don't actually save it. It's just used as a local variable. And ignore means that we're not looking ahead. We're still parsing the bits, but we're dropping those bits. So I use those in some situations, like the plus means look ahead, so it means we're looking ahead 8 bits to see what's next. I don't want that next to be saved like header or logical screen, data, or trailer, which are the actual parts of a GIF file, right? So that's implicitly a local if it's a plus in front, and it's also doing a look ahead. And there are other places where I totally ignore it. Maybe not in GIF, but like in this test, here we're parsing as an unsigned integer some number of bits, and the minus means I don't actually want to save it. And I'm doing that to avoid an issue right now where when we loop more than once, it's going to collide with itself. Eventually, I want this to work without ignoring it. And the way that'll work is because it's in a loop, inner will actually be a vector. And every time we loop through, we're populating more indices of a vector called inner. So you'd have, at the end, you'd have foo dot inner, and then you'd have a vector. So I don't support that, what I call vector context yet. So right now I'm saying ignore it, which means that this now becomes a local variable, so we could use it if we want, but local variables can be reassigned, and at the end it shouldn't exist. Like it's deleted. Which leads me to another thing. Should I cease to exist outside after the loop is done? Or should it continue to exist? Like, I'm thinking like there are three possibilities. Either we just it always stays around as a local, so we can always do that. Or it never stays as a local, so this would return, this would be an error, it's an unfound I. Or the third possibility is we allow it to find I, but only if it existed before the loop. Oh, thank you, C17R. Why would it cease? Is to find outside the list, right? Outside, yeah. So that's that third possibility. If we define it outside the loop and we're just reusing it, it probably should, we should be able to use it, right? But what if I didn't? Like, actually, what if I like returned I here? Should I allow that? Right now it will work and it'll be 0. Right? So this will pass and say it's 0. Hold on, I have a bug. I need to call it foo. All right. So that passes. We get 0 for foo's value because we returned I, which is, so it leaked. Basically, we're leaking the name I out of the for loop. If I don't want that, then I have to remember at the beginning, did I exist? And if not, then we need to remove it from the locals at the end of the for loop. I kind of think that we should do it the clean way where if we just use it locally, like if it didn't exist as local, then it shouldn't exist outside, right? And I kind of want to duplicate the test to prove that. So this is using loop variable test for loop variable, test for temporary loop variable. Should not exist outside loop. So here, if like we return 0, then this should actually be a none, but it should be an error. We should get an error, but we still parse 2 bits or 16 bits. And if it's an error, it doesn't matter if there's a value. So I, right? So it should still do all the parsing, but I shouldn't exist because it didn't exist before loop. And this is going to fail now because it's going to say there was no error. Yeah, assertion failed on foo error, right? So to do that, we have to actually remember to remove it. And that all comes down to whether it existed at the beginning, right? So this thing does this require existing? False. It's used down here if the entry was vacant. So it doesn't require it to be existing. So it actually insert it here. So I need to remember if it was, I guess we could just check to see if it didn't exist before. So before adding it, we can just see, we can remember if it existed before or not. So let's just keep it simple, and let's say loop var is temporary, and we'll assume that it is true, but we'll also do a check here. Actually, I can make this a little bit cleaner by doing a let else, and then moving these two lines up to there, putting a semicolon there, and then this gets outdented. Then we can actually compute this properly. We can say it doesn't need to be mutable anymore. It could just say if self.locals.get loop init. No, loop var is none. If it didn't exist as a local, then we're going to remove it at the end, right? Hey there, Spoof. Why would it cease? It's defined outside the loop. Oh yeah, so we were looking at two different contexts, right? If it exists outside the loop before the loop begins, then we don't want to remove it. But if it didn't exist before, I think I don't want it to exist after. Is there a contains? Oh, okay. Thank you. So it's the same as get is none, except for I have to invert it, right? Thank you, Spoof. You get one useless internet point. You need to have 3 of them. So it's out here. Well, actually, hold on. I have to do it. I should do it down here too, right? Let me think about this. On errors, it doesn't matter. I don't care, right? But I do care if we do a break or we do a return inside the loop next. And Rust doesn't have the concept of doing something on the way out, does it? Love you some useless internet points. That's right. So what would really be cool is if we could say like on exit or on return, something like this, right? But I don't think such a thing exists. Actually, it would be even better. You know what would be even better is if we didn't even need the variable. We can just say if not, then on return self dot remove, like it's remove child, loop var. But such a thing does not exist, right? On return. A scope guard, copy link. Am I learning something new? I like learning things that are new. Oh, I put an E on the end. Why did I do that? I had to pick up a crate for this. A scope guard will run given closure runs the scope even this code between panics. Does it get the return value? That would be perfect. If the scope guard closure needs to access an outer variable value, what I'd want is like, I'd want the thing that's about to be returned. Because like, really what I want is not just that, but I want to say, like return value. Well, I guess I don't really need to, but I was kind of thinking it would be cool if I could say if return value equals return if it's not equal to returns, try that again. Not equal to return scope error. Then remove the loop variable. Yeah, but would my own RAI type work with that? Like if I wanted to peek at the return value, because if we return an error, I don't need to do it. I only need to do it on next, on return, and here. I could just make a function actually, right? And just call it. That's probably the closest. So then here's what we can do. We can let cleanup equal dot then sum return value. Well, let's just not care about the return value for now. I'll make it simple. Just do that, right? So if I do that right, I should have an optional function. We have to like borrow self, so this. Because I can't move that reference in, can I? I guess I can because no, I can't because it's on construction here. So this has to be like, we'll just call it on itself. So yeah, I need to make one of these anyway. Let's add that first. Context. I don't have like a remove, do I? I just have an add. Actually, what did I do for locals at the end of a statement? Do I just like, am I just like doing a, hold on, let me check. I think I just did for local and locals remove it from key children or something like that. Where was that? Like ingest component or something? Finalize locals. Yeah, I just did that. So then, because locals is part of the context, I have to do something a little bit more. Well, we'll just manually do this. I'll say this.composite.keyChildren remove loop var and this.locals dot remove loop var. Okay, yeah, so I should get an optional function, right? So then the idea would be we would just have to there and there and there clean up. And then I don't need this unnecessary thing there. Oh, I gotta say this dot, right? Or self dot. Or actually it's clean up this. Or clean up self. Why can't I call it? Found, oh, shoot. Crap. If some cleanup equals cleanup, then we can do that, right? If let. So that doesn't look very clean, no pun intended. Hello, buffer AA55. And cap has an hello. Seg falter. This mute self. Yeah, that's what I ended up doing. Function sounds it sounds easiest, but like this is sort of gross. What if we just always have a cleanup function and then that function like encodes whether we're doing it or not? Could cleanup map f self, but Clippy might yell at me. Yeah. I could just make this simpler, right? Let cleanup equal, and then turn this around. And we have to do like, I guess we're capturing this one, right? Let loop var is temporary. Like I had this before, right? Not. And then if loop var is temporary, do this. Then get rid of this. Now it's not an option anymore. And then we remove the if let sum, all this stuff, right? Delete that line, delete that line. There we go. Now, the final thing would be if I could just always have the cleanup function be called no matter what path we take on return. So that we were talking about using an RAII thing, right? I could make one. So struct what do we call this thing? Like we can just call it a cleanup function. Cleaner? I like cleaner. Yeah, exactly. Make it generic on some function that takes mutable reference to context. I'm trying not to just type what you typed in chat because I want to make sure I can do this myself. Can I just like put the F in here? And then implement drop for cleaner. Actually, you know what I can do is I can just say, hold on. I can just say where. And I can remove this, right? So you can make one, but we only implement drop for that where that's true. Okay, what's wrong with that? Struct is not supported on traits or impls. Because it's inside of context. Let's temporarily put it here. Implement missing members, and it would just call self.0 self. Hold on. I need this name, right? Oh, it has to be more than F. We have to actually stow. No, we don't. It can't be drop. It has to be a function. We have to. No, hold on. We have to put a reference in there, but I can't because it's mutable. This is a problem, right? Let's see. Let's see what chat said. That would have set the bar checker probably because it would need to borrow self. Yeah, fn once. Also can't define a struct inside an impl block. Yeah, I figured that out. And can't have conditional drop impls. Yeah, this is not going to work because we would have to stow a mutable reference in there, and then we wouldn't be able to use it. So I do need to pass an argument to it, so it can't be drop trait. Yeah, so this is just not going to work. Hey there, Mr. Balrog. You accidentally rubbed ketchup in your eyes and gained a superpower. Now you have Heisensight. I see. I'm trying to think. Hindsight. Oh, hindsight. There we go. Now it's more funny. Pub Mutable reference to option context. Pub mutable reference to option with a mutable context in it. Yeah, but you can't define a type inside of an impl, right? Set that when you can. Kind of lost where I was. For statement, right? See this, I kind of with this I deferred needing the mutable reference until we actually call it here to remove stuff. Yeah, it's the fact that when we're done. Oh, I have an idea. Oh, I gotta go to a meeting? Shoot, I'm out of time. I gotta go to a meeting in 5 minutes. Here's an idea. We could wrap the entire function into another function that sets one of these up, and then like it calls the inner function, and then on its way out it does this. So like we could just do this part only. We could just do that, call the inner function, and then on the way out, if the return scope is, we can even do if the return scope is not error, then do this, right? I think that's what I'm going to do. So that'll be probably later today or tomorrow morning. We'll fix this by splitting this function into two, and the outer function will do the cleanup. Okay, I don't have time to look at that, but I'm going to copy that link and say to do check out. Oh, will it last until tomorrow? Your gist on the playground? If it will last, then we'll leave it till next stream. Something like that might work. It's permanent. Okay, cool. I'm gonna check that out when I can. But yeah, I got the little 5-minute reminder that I got a meeting to call into. Well, not many of my friends streaming right now, so I got to pick someone who I've been streaming often or selecting often. Oh, wait a minute. Kuvaman is streaming? Let's stream Kuvaman because he streamed me. Here we go. We're returning the favor. Rating someone who rated me the other day. Kuvaman. Working on software and game development. Hey, that's what I was doing. Software. Okay, see you guys later. Have a great day or great night. All right, bye. Bye-bye.